Hello everyone, this is Bradley. So today this is a voiced recording again for this kind of a trail smoke animation. I haven't come up with a title. I will do that later. Initially I tried to do something else, but after really thinking about that, I think it would be rather annoying because it's too complicated. So today we're going to do this trail smoke. This is kind of inspired by the trail extrusion animation I've done earlier because it's, how should I say, I'm not very satisfied with that result. So let's do something more kind of realistic. So as always, I'm going to use the presets from my library. You can download them for free from the link in the description. And this is going to be 3.1. So let's start. So here in Blender, let's just add a whatever stuff. I think this time I'm going to randomly generate a path for that. So let's just delete the group inputs. And I need let's just create a curve linear. And let's use the set position. Here I'm going to use the if I use noise, probably not gonna work. Let's just do a actually sometimes this is kind of tricky. Let's just try because I'm not sure which one to use. So let's turn on with a noise 3D and turn on this scale. Looks kind of very ugly. I try to do a vector mass so that it only generates on the ground. So 110. Okay. Can I change the seed to get a kind of nice result? It's not too bad. It's just kind of very jaggy. Maybe we can make it less jaggy if we try to decrease the frequency. And we can also increase the count and see, not really nice. Oh, actually this is cool. Not 100% ideal, but I think we can change the seed until we get a kind of good enough path. As long as this is a random path, I think it will just be fine. We can also try to decrease all these kind of values and try to see the result. Okay. It's also possible that we add a smooth curve so that this kind of edge can be smoothed out. So I think as long as we get something like this should be fine. Let's try with the trim curve. And we have this path being drawn. Okay. Let's set curve cyclic. Set spline cyclic. Yes. If we turn on this cyclic, we cannot trim that. Okay. So I have to use another node, which is reset spline cyclic. And oh wait, I need to set the cyclic back. Hey, it's not working. Oh, that's a bummer. Hey, why it doesn't work? Oh, because it trims successfully. This is Jesus Christ. I was almost scared. Is there any bug with my presets? But we do realize there is some issue, like the end is not very perfect. So I think I'm going to do the resample curve so that to increase that as much as possible, so that in order to keep kind of shape. Yeah, I think something like that. We can use the length so that it can be more smoother. As long as we get a kind of shapes or whatever stuff, I think it will just be fine. I'll just leave it right now because we already have the ability to trim. Okay. Trim is not very important. I think it's just when we trying to follow the path. For example, let's just make a flow path or follow a spline so that we can create an endpoint. But on the other side, actually this is a single spline, right? So we do not really need to follow splines. We can use a sample curve. It really does not really matter. It depends on how you're gonna to work with it. So let's generate an icosphere. And we need to transform it. So basically for multiple spline, you use the preset. For a single spline, it's possible that you just use its sample curve. The issue of a sample curve, as I've explained in my tutorial, is that it does not work for multiple splines. And let's plug the rotation into place. There's a red line, but you do not need to worry about that for now. And let's just view the geometry. We do not need the trim curve. And you can see how it moves. This icosphere is too large. Let's decrease its size to 0.1. Let's join two geometry so we can see if it's really working based on the path. Okay. And by manipulating this factor, we can see how this ball or icosphere is running into place as we wish. So if we want to loop it, then just do a mass fraction. So now we can actually just move that infinitesimally without any problem. You can go forward and backwards. It's okay. Okay. So after this moment, this is completely cool. So just again, although there is a kind of red line, but you do not need to worry about that because it's functioning pretty well. Actually, whether you have a red line does not really matter in this particular case because this is a sphere. So what if I'm not using the sphere? Let's switch that to the cube, to the default cube. I think it will be a brilliant idea if we're trying to make the default cube to work. And then we can play, and you can see the default cube is oriented pretty well in this scenario. So let's just use default cube and we can decrease the size as 0.2. Okay, so this is cool. Okay, then we are trying to generate smokes. Okay. Generating smokes is kind of difficult. So here we're going to combine two techniques. One is when we are making the pedal animation. The other is when we're trying to make the smoke to disappear. So basically the type 3 stylized smoke effect we're trying to do. Okay. Last time when I was doing the stylized smoke type C, basically I was replicating a Unity tutorial, but because it's a noding, so it's a moment to study, not really a reflection of what I've learned. So there are some parts which I disagree with the original tutorial. Let's basically So if now I were to think about that, there will be a lot of things I will change, probably, because I do not really understand the necessity to increase the complexity of their setup. But anyway, I don't know. Sometimes you have to try so that you see the difference. But anyway, going back to our setup, I would like to distribute the points on this path. While I do have a preset which is called array on spline, but since we would like to produce as many smoke as possible, I think bevel curve to generate mesh is much easier, so that we can distribute points on face. But to control the amount better, I'm going to use the point distribute presets so that I can control the amount. So let's say 1000, which is not enough, so 50,000 or 5,000. Yeah, this should be fine. Okay, we can definitely procedurally control this kind of amount, but for a moment I will just keep it as it is. Okay. So, and then next is a little bit about the particle emission on this kind of spline. This is a little bit similar to what we have done on the hair or the fake hair physics animation. What we are going to do is, because we need to know the direction. Okay. The direction for these particles to move, which is about the tangent of our spline. So we need to capture. So we need to take the tangents. Let's also take the normal as well, just to be safe, because I'm not 100% sure which direction it's moving. Tangent must be right, but other things might be very tricky. Okay. So we take a set position, And basically what we need to do is the vector mass with the scale and see how things respond. So by tangent it's moving in that direction. We're also going to take the vector mass maybe on the axis. I'm not sure how to do this. Let me think. So we try to combine x, y, z. And let's use a single value to control the z and the scale of the tangent so that it moves on both tangent and the up vector. Something like that. Right now this doesn't look like right at all, but I think as the time goes it will be better. Once we generate a kind of fourth, this is basically the expectation. So let's try. So to trigger the animation, we need to animate the curve parameter as we've done with all this kind of hair particle deformation, which we need the curve parameter. So you can do another capture, or you can use the UV, but I'm not going to use the UV. I'm just going to take the curve parameter. So let's take the float, and we have a curve parameter. It's actually spline parameter. Oh Jesus Christ! I speak the wrong name all the time because they changed the name from curve parameter into spline parameter. I hate this. But this really makes sense better than the curve parameter. But just I didn't get used to that. And we add a math node. Actually, nowadays you can link, drag, and search. But I also don't get used to all these kind of workflow changes. Sometimes this is the part which is very difficult. And the link, drag, search actually won't read all these kind of presets. So there is no G nodes for my presets. So this is also a part which I don't like for the moment. And we take a fraction because we're going to loop that. So here another thing that we know is we're playing this fraction so that the cube is moving. Okay. And adding the value, the cube is moving. But here I think we're trying to reduce the value. Well, we will see exactly how it works. But the question is how to make it work. So basically we're using this value to control the movement, right? Okay. So to finish this movement, we're going to use this value. And we can see this is how it's going right now. Okay, so this is cool. I want to call your attention that previously we see our cubes is moving basically in this direction. But if we're trying to add in the value for our parameters, then you can see this spline is actually moving the opposite direction. So this is something we learned from experience about the hair physics or other things, that we need to use a negative. So that for one value we're using the negative value, for the other value we're using the positive value. So once you synchronize them, you can see they're actually at the same locations. And then you can see this kind of cube is eating the lines. Okay. Right now this viewport it looks kind of very chaotic, so I would try to do something to deal with this chaotic issue so that we can move on to the work much more easily. So here whatever we're trying to work is the points. So we're visualizing these points as well. I think we do not need to worry about the points for the moment, even though by the end of the day I think by the end of the day these kind of points will be the particle system in the future, and we should be able to render them. But this is too early to call in 3.1, so we're not going to talk about that. We still have to use the instance And let's take an icosphere. And let's decrease their size. So add maybe 2 subdivision and decrease their size. 0.1 should be okay, because we're going to change the size. Okay. Knowing that right now we're adding the parameters and the fraction data, so that we're looping the parameters. So this parameter is basically the lifeline that's generating the animation of this kind of floating effect. So here what we can do is to take a map range. Actually no, we need a color ramp. And let's control the scale. I think I'm going to use the color ramp to drive the animation as well. But I think the scale is more prominent. So basically if we crush this black value, then we're making the viewport much cleaner because we only have limited amount of the splines being generated. So this is good, while we also see the issue is that the cube is here and the smoke is there. I think the issue is that we are making the tangents positive, so we need to make it kind of negative. So let's just add a negative. Just multiply negative, so that yeah, you can see it's flying here. But this is also not what we're looking for, because we want, obviously the smoke should be that direction instead of this direction. Okay. It should gradually fly instead of depressing itself over the path. So we're going to fix that. Another thing we need to fix is, right now this is just it's still a single line, but the smoke obviously should spread out. So there are 2 kinds of issues we need to fix for this smoke. To fix that issue, it's kind of very simple. That since right now this is 1 to 0, but our desired is 0 to 1. So we just reverse the relationship of our color ramp. Then it will fix the issue. As you can see, there is a elevation as we are looking for. Okay. And by crush the color ramp, we can limit the amount or the range of this kind of effect. There is definitely also another fix that we have made, that this smoke starts to be small and they becomes larger. If you really think about the animation, then this is actually an expected behavior, although previously we also mentioned that we want all this kind of sphere to disappear. But considering later we're going to realize all this kind of sphere and delete geometry to make a kind of smoke disappearance effect, then this won't be really a problem. Okay, so basically we're going to use an alternative method to make all this kind of sphere disappear, so that you won't see them at all. Okay, so right now this is almost a fix. Next, we're basically just going to add randomness so that they are less likely to be actually a single spline-like. To make the randomness, it's kind of very simple. Right now, this entire movement is determined by curve tangent and this elevation. Okay. So what we need to do is just add another vector mass and add some noise. Okay. You can definitely use the noise texture, which is basically noise 3D. But in this case, since I just want randomness without any relationship, I'm just going to use the randomness, which is basically a random value in the vector mode. Okay. And immediately you can actually see this effect. Okay, so we basically finished this effect, and I just want to do a map range so that the minimal scale will be a little bit larger than it should be. Or you can actually choose the east or whatever other stuff, so that make sure this kind of transition. Okay, so I think this is good, and I really think this is very ugly with all this kind of sphere. So I'm going to delete them. To delete them is kind of very simple. So you just realize the instance so that you can access every point of this sphere. It's definitely painful, but there is no other way to really do that. And I also need to capture attribute, the position attribute of our icosphere. There are some reasons I'm going to do this, because I would like to use the position attribute of our each instance. Let's take an attribute instance so that we generate an index. This is because I would like to use this index to drive the seeds for the deletion, and then use the deleted geometry, take and compare, greater than. This is integer. I hate that. Okay, greater than. Let's take a let's say normalize field. We basically would like to normalize the noise that we get. So in this case, let's get a. You can use noise texture, the noise 3D, or you can use the word noise 3D. They have pros and cons in each of them in terms of deletion. So we have to try them, and then let's see what we actually get. Okay. So we use the captured attribute as a way of evaluation, and index as a seed. Okay. Let's organize the tree a little bit better so that we can actually see the relationship more clearly. Okay. So greater than 0.5 should be deleted. Right now, we plug that into field instead. So right now you can actually see how they are behaving like. Basically, every of the sphere is being deleted by half because of this relationship. It's greater than 0.5, and if it reaches 1, then they appear. Okay. If they less than 0, they will be deleted. So here, let's just try to use the less than, because we want to kill these particles at 1. Okay. So basically, to animating the disappearance, we use this less than, right? And we need to connect this threshold to the value that we use to drive the animation. So I think we can directly plug this color ramp into place, and you can see this effect immediately. Okay. And knowing that this procedural setup is essentially all driven by the previous negative number that we generated, so that we have a cube, and it just goes, we have smokes to be generated and it disappeared. And basically this is kind of concept. You can definitely tweak a little bit more, because I realized the relationship of this scale and the combine XYZ is wrong on my side. So we can change some order of them. But that's something I will do in my free time. There's nothing, at least you see how it works right now. And this is basically it. Right now, this setup may be a little bit heavy. It's 245 milliseconds. How many instances did I actually create? It's 5,000. So considering other situations, it may have more instances. So we need to find a way to optimize this setup a little bit. In such a case, the easiest way is always to not to instance these many objects that we are not going to see. However, if we do not instance all this kind of sphere, then the index will be changed. If the index has been changed, the seeds of our noise will be changed. If the seed of our noise is being changed, then this kind of deletion will be changed as well, because they aren't using the same noise from frame to frame. This will lead to a kind of glitching effect when you play this animation, because from frame by frame, they are not using the same noise. Okay. So we cannot use this selection. Instead, we're going to separate the geometry only after we capture the index. Okay. So that the same index can be passed through to the future geometry. Okay. So we separate the geometry, or you can use the deleted geometry. They're basically using the same code, so there's no real issues. Whichever you like, it's the same. Okay. And the geometry that we're going to delete is basically all this kind of threshold which reaches to 1. So this color ramp which has the 1 value output. So in this case, we just take a compare node, and we're using the greater than. It's giving the color. Okay, all right. So here, let's use the using the float, and let's give that equal to 1 as a criteria of a selection. So immediately we lose everything because it only outputs the values which equals to 1, and this 1 value is being deleted later with our deleted geometry. So we use the inverted selection instead. And now basically this is finished. Okay. The rest is just increase the subdivision, play the animation, and so on and so forth. And you can also tweak all this kind of value. For example, you can make that east, cardinal, whatever you want. But this animation is basically being finished. Okay. You just give it a time info, because I do not want to keyframe these values. So let's just say 555, which means it takes 555 frames for this cube to reach its original location after the entire cycling. So now we can actually play this animation. Okay. The rest is all about the tweakings, so I'm not going to go through all of them. Knowing that sometimes things are not necessarily difficult, it's just the more controls you want to add, then the more settings you need to add. For example, you want to add a float curve to change the interpolation and so on and so forth. For example, there are so many things that you can do, so I don't want to touch them because this is already kind of a large node tree. This is simply because we're involving multiple concepts from different tutorials, but basically all of them are being covered in the past. So we're just refreshing the memory to make something more complex. So I hope you enjoyed this tutorial. I'll probably see you next time. Bye-bye.